This is a shot of the gantry, and you can see the base of the gantry legs. It runs on inverted angles. That drive system right there is a variable frequency drive motor and a gear reducer that directly drives the wheel. There's one on each side, so you don't have to worry about it yawing or trying to crawl sideways as it moves down the length of the thing. Ultimately, it's not a rack and pinion drive, it's a friction drive. It's a V-grooved wheel on an inverted angle track. And the reason for that is safety. If you had a rack and pinion, like on a plasma cutter, and somebody ever got caught up in the drive or between the frame that's being worked on and the drive, it would damage them or hurt them pretty badly, whereas the friction drive ultimately would slip if it was completely jammed up. Here you can see the long cross piece that comprises the gantry, and so these are the welding heads. This particular machine is rigged up to weld with twin wire weld nozzles. You've got two welding heads, one to weld on the taper side flange, if it's tapered, and one to weld on the straight side flange. And you can weld frames down to about 7 inches deep and up to 72 inches deep. This particular machine is set up to run two 1.6 millimeter electrodes in each weld nozzle. There are flux recovery units for each weld head that dispense the flux and recover it at the same time. Over to the left is the operator control station where he can see the weld heads and access them. Both the weld heads are on the near side of this main cross beam, kind of like a plasma cutter, and so it's easy for the operator to get to them and work on them or change out tips or whatever. These small little stirrup looking things are what we call pear-shaped links, and there are 4 of them welded on to make it easy to lift it for material handling purposes, for loading and unloading. This particular machine is set up with 2 DC 600 welding power sources.